Welcome friends, in this tutorial I will show you how to stress and deflection analysis of 2D truss by using a Ansys software. So here there is a one problem statement. So in that we have to calculate reaction support and nodal displacement. Also plot the displacement vector and stress contour. So take E is equal to 70 GPa. Then Poisson's ratio here is a 0.3 and uniform cross section of all area for each and every element is a 150 mm square. Okay, so there is a total 8 key point A to H, and there is a 4 load apply over H, G, F as well as B element. Okay, sorry, B key point. So there is a total 4 load here is apply. In that D point is a fixed support and A point is a roller support. Okay, so let's start. Okay, go to preferences, structural, okay, preprocessor, element type, add, then there is only one single area, so we have to check a link 3D finite, okay, then close, real constant, add, edit, add, okay, then what is the area value? So area value I think is a 150 mm square, so 150. Okay, so see here there is a one problem here. Total dimension in that there is a in a meter. Okay, so means see here there is a length is a 2 meter. So I think you can put also in a mm. So I will put a mm and then this dimension in a also put in mm. Okay. So 150 mm square, then okay, then close, metal property, metal model, then structural, linear, elastic, isotropic. So there is a 70 GPM, means 70 GPM is gigapascal. So 70 into 10 raised to 9 Newton per meter square, but we have to convert into Newton per mm square. So there is a value is 70 E3 means 73 megapascal means Newton per mm square. Okay, so there is a conversion. Then Poisson's ratio is a 0.3. Then okay, then close, then go to modeling, create, key point, inactive CS. So first point is a 0 0, so apply. Second point is a 2000 because there is a 2 meter. And y is a 0, so apply. Then here is a 4000, apply. There is a 6000, then apply. And there is a 6000 and 2000, then apply. There is a 4000 and 2000, then apply. See here. Okay, then there is a after 4000 there is a 2000, then apply, and then is a 0, then okay, so there is a total 8.8 key point we have to create. Now go to line in active coordinate. So go to 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, then 8 to 1 again. Okay, so remaining portion is a in between there is a cross section. Okay, so let's start from here to here, here to here, here to here. Okay, then 7 to 2 and 6 to 3, then okay. So there is a element is created. Now after modeling we have to go to meshing, mesh tool, then line set, pick all, there is only one element, then okay, then raise hidden and mesh, click on pick all, then raise hidden. So raise hidden here is a close because meshing is done. Okay, now after that meshing we have to apply load, define, apply structural displacement on a key point. So here is the roller support. So okay, there is only y is a 0, then okay. Now another is a D point fixed support. So on a key point, select this one, okay. Then all degree of freedom is a 0, then okay. Now after support, we have to apply force. Okay, so first force is a 25, 10 and 15. Okay, 25, 10 and 15. So force moment on a key point, so from here first, okay, I think is a correct, okay. Then is a downward, so Fy minus 25 E3, then okay, on a key point here, okay, there is a 10,000, means a 10 E3 or 10 kilonewton, then okay, then again key point, now here, okay, there is a 15,000 or 15 kilonewton or 15 e raised to 3 for a F point. So okay, and one force is here, okay, 20 kilonewton. So again on a key point, select here, okay, then select minus 20 kilonewton, okay. Now okay, after that all our process of load applying is done. Now go to solution, then solve current load step, okay. Okay, solutions are done, close. Now general post processing, then plot result, deform shape in the deform and deform shape, okay. So go to report generator, append, okay. So capture this image, okay. This is the first result of this graphical result. So there is a black line is nothing but the original or undeformed shape, and this blue line is a deformed shape, okay. After that go to control plot, nodal solution, then degree of freedom solution, displacement vector sum, then okay. So there is a, see here, total displacement is at 27.84 is a maximum displacement, and there is a apply at point B, okay. There is a two load applied is downward side, so there is a maximum displacement. Next element solution, stress 1 means stress theory, then okay. Okay, so see here there is a no stress is available, no stress is a show. So go to plot control, style, size and shape, then E shape display of element is here is a check on, means on, okay. So 235.702 Newton per mm, this is a stress value, okay. Now after that we find out the tabular value, means list result, then nodal solution, degree of freedom solution, displacement vector sum, okay. Okay, so this is a tabular value of this total 8 element, okay. Then okay, not 8 element, 8 key point, okay, sorry. Then element solution, stress, then 1 means stress 3, okay. So there is a total element, I think 13 element. So 13 element, there is a different stresses. So see here there is a stresses value 133, then minus 100, then minus 47, etc. So there is a total number of stresses. Then another portion is the reaction solution. So all items they know, okay. So see here reaction solution, there is a value for first point is y direction is a 50 kilonewton, and for fourth point there is a x and y reaction, one is a negative and another is a positive, okay. So that's it, thank you.